Hi students, I hope you all are fine. Yesterday we have learnt about the solid state in previous classes about the packing efficiency of simple lattice and face-centered cubic lattice and body-centered cubic lattice. Now I will tell you how this Bragg's equation was derived, and this is foremost important question in second year intermediate public exam, and how we have to write in exam, okay, to score more marks. Here see what is meant by this Bragg's equation, or who proposed this Bragg's equation, or what is this Bragg's equation? Means first of all, W.H. Bragg proposed this Bragg's equation and got Nobel Prize in 1913 By using X-ray diffraction, Bragg's equation can be determined. What is the use of this Bragg's equation? Means it can determine the relation between interplanar distance. It can determine the relation between interplanar distance, that it is d, and wavelength of X-rays, that is lambda, and angle of diffraction of X-rays, angle of diffraction of X-rays, that is theta. Okay, understand students? What is the use of this Bragg's equation? Means it can determine the relation between interplanar distance d, wavelength of X-rays, and angle of diffraction of X-rays. If you observe crystal lattice, what happens? If you observe crystal lattice, in that lattice atoms, molecules can be arranged in a regular manner. These atoms or molecules are arranged in a regular manner in this way. If you observe the crystal lattice, atoms or molecules are arranged in a regular manner. In this arrangement, for example like this, in this way crystal lattice was formed. Here these are called nucleus. This nucleus is nothing but lattice point. This nucleus is nothing but, what is this? Lattice point. Okay. If you take two lattice points, I am taking these two to explain you. Taking two lattice point, this is a nucleus. Simply it is a nucleus. From this nucleus to this, it is called atomic radius. It is represented by R. From this nucleus to this, it is also called atomic radius. It is also represented by R. That means the distance between, okay, here two R's are formed. It is called radius, atomic radius. Here the distance between these two is determined by d. That is nothing but interplanar distance. In this, two terms are there. Before entering into this Bragg's equation, we have to know two terms. One is constructive interference. And another one is destructive interference. Let us see what is this constructive and destructive manners or interference. First of all, see, this constructive interference means, what students? Constructive interference means, see, just simply I will explain you. If we send X-rays like this, if we send first X-ray like this, or another X-ray also, second X-ray also, see, in the same manner, another X-ray also, just in the Then if we add these two, then we get these type of wave. This type of wave finally. Okay, if first ray of X-ray is sent like this, second ray is also sent like this, then which type of wave is obtained finally? Then we get this type of wave. For example, here the length is 1 unit. How much? Here the length is 1 unit. Here also the length is same, 1 unit only. If we add these two, then how many units are obtained? Here the length is 2 units. Observing these two, we can say it as this is constructive interference. That means the length increases at the end of the formation of the wave. The length increases at the end of the formation of the wave. This is a constructive interference. Did you understand, student? For example, if I send first X-ray in this manner, then second X-ray is also in the same manner. Then if you add these two X-rays or waves, then we get this type of wave. Or here the length, this is upward direction now. This is also an upward direction only. Suppose this length is 1 unit. This length is also 1 unit. At the end, if you add these two, we get 2 units. Let us see the second interference. What is that second interference, students? Second interference, that is destructive interference. Second one is destructive interference. Destructive interference. What is meant by this destructive interference? We have to see. What is meant by this destructive interference. Let us see. Okay. See, suppose I am sending a wave like this. If I am sending the first wave like this. I am sending the first wave like this. The second wave like this. Here in the reverse way. This is an upward direction. This is the lower direction. Okay. If we add these two, then this type of wave will be obtained. Then this type of waves will be obtained by adding these two. Okay. Here if we add these two, this is positive and one is negative. We get this type of wave. Like this, here upper one is negative and lower one is, upper one is positive and lower one is negative. So it get cancelled and become what? 0. Simply one example I will tell you. For example, if you see sound waves. If you see sound waves, what happens? Sound waves. What happens? Here, if you take sound waves, this is a sound wave. First ray is a sound wave like this. Second ray is this sound wave in opposite direction. Then after adding these two, we get this type of wave. Here opposite signs are get cancelled to become 0. That means there is no sound will be observed. Another example I will tell you. Noise reduction earphones if you see. Lively example. Noise reduction earphones if you take. What? Noise reduction earphones. It follows only destructive interference only. How we can tell? If we put earbuds in our earphones in our ears, then what happens? One ray will be passed like this and our cell will be passed terminated signal like this. Then what happens? Positive and negative get cancelled. Then outer sound will not be obtained. There is no sound wave will be obtained. This is an example for destructive interference. This is a small introduction of before the Bragg's equation. If you observe Bragg's equation follows only constructive interference. Bragg's equation follows only constructive interference. That means what? Constructive interference. That means First one, constructive interface, this one. Okay, that means the 1 unit and 1 unit to add become 2 units at the end of the wave. Okay, in the similar way only. Here see, in Bragg's equation, suppose I will take in Bragg's equation, if you observe crystal lattice, see, these are the lattice point. These are the lattice points. Simply it is called, it is an what? It is called lattice point. Simply we can call it as nucleus. Lattice points. Simply it can call it as nucleus. This is a first ray or layer 1. This is the second ray or layer 2. If you name it like this. Here, suppose if an X-ray is passed through the first ray, this is the incident ray. If an X-ray is passed through the first ray, this is the incident ray and the other ray is reflected ray. Okay, suppose I am doing like this. I am keeping as it is an incident ray and this is the reflected ray angle. If I will make a line like this, the angle of this one is reflected and the angle of this one is incident. Then both of the angles are equal. Angle I is equal to angle R. Okay, here angle I is equal to angle R. If you take here theta, or if you take theta, then both the thetas are also equal. Both the angles are also equal. If the second ray is passed, same incident ray and this is the reflected ray. The second ray is passed. If a line is drawn like this, then what happens? Theta. Okay, we have to, here also both the thetas are equal. In this, what we have to find in Bragg's equation means we have to find the interplanar distance. That means the distance between these two. If you find this distance, we can easily calculate the Bragg's equation in sums also. Okay, students. Then I am keeping like this: A, B, C, and O. This point is, name it as O. If we find out these values, we can know the planar distance. That means path difference we can know. This second ray must be sent more when compared to first ray. It is very important point to note down in our exam. Okay. See, here these two thetas are equal. These two thetas are equal and these two angles are also equal. See, if you observe this triangle, what happens? I will draw like this. See. If you observe the triangle, which triangle? This triangle. Which triangle? This one. A, B and O. This triangle. A, B and O. This one. A, B and O. This is called distance D. This is called OB distance is nothing but D. Then triangle OAB. See clearly. OAB. Then triangle OAB can be written as, how it can be written? In trigonometry forms. Sin theta. Here angle is there. Or it can be here angle is there. Then sin theta is equal to AB by OB. AB by OB. Okay. AB by OB. Here OB we know D. AB by D. Then AB is equal to D sin theta. Okay. If we find it as equation 1. Then AB is equal to D sin theta. Then take the another triangle. Which triangle? This triangle. OBC. Then in trigonometry forms, how can we write? In triangle OBC, Sin theta is equal to, how we can write? See, BC by OB. This OB is called distance D. BC by OB. Then BC by OB is nothing but D. Then BC is equal to D sin theta. We know that the values of AB and BC. Values of AB and BC. Suppose if we think it as 2. Important point. According to Bragg's law. Note. According to Bragg's law, the path difference is equal to an integral multiple of, if the path difference is equal to an integral multiple of wavelength. Okay, understand? This is very important point. Integral multiple of wavelength of X-rays. Then waves of X-rays, two X-rays exist in same phase. Then waves of two X-rays, what happens? Exist in same phase. Did you understand? This is very important point. You have to note down in our exam compulsorily. Okay. If the path difference, according to Bragg, if the path difference is equal to an integral multiple of wavelength of X-rays, then those two X-rays exist in the same phase. Here D is nothing but path difference. Then how can we write, student? That is the path difference. AB plus BC is nothing but D. Okay. AB plus BC is equal to what? D. We already know those from two equations. AB is nothing but D sin theta. BC is nothing but D sin theta. D sin theta plus D sin theta is equal to D. Okay. D is nothing but, it is an integral multiple of wavelength. Okay. Then D sin theta is nothing but 2D sin theta is equal to n lambda. According to Bragg's equation, this is the equation for constructive interference. This is for constructive interference. Then you will get doubt. Then what about destructive interference if it can be given? Then what means 2D sin theta is equal to m lambda by 2 is for constructive interference. 2D sin theta is equal to n lambda by 2 is for destructive interference. In exams, in sums, if they ask for constructive interference, the formula is n lambda is equal to 2D sin theta. For destructive interference, remember this. Destructive interference, the formula is 2D sin theta is equal to n lambda by 2. Or it can be written as n lambda is equal to 4D sin theta. Remember this. For destructive interference, n lambda is equal to 4D sin theta. And for constructive interference, n lambda is equal to 2D sin theta. Maximum we have to use this constructive interference only for Bragg's equation. Okay. I think you like this video, students. If you like this video, please subscribe my channel. It will give more updates for you. Thank you.